Hello, do you believe that if I run this 20 line of code, it will create me a video automatically based on the prompt or based on the sentence that I write it here? Here I have written a cinematic dragon flying over the mountain at sunset. So I need that video to be created. If I run this particular code, I'm going to get a URL where you can download the video of that ask. When this code ran, it has returned me this output. The output, as you see in this screen, it has a video URL. Now we're gonna do a control click on this one, which will open the URL in the browser, and it will start to download the video. The video that we expected in the form of a text, right? So we written what you want in a video. Now that is presented in front of you, where you see that a cinematic dragon flying over the mountain and the sunset, and that's a magic, right? So how to build this solution? If you want to understand, please do watch my this lab, where I have shown you from scratch to end. And if you need an enterprise services or freelancing around these technologies, do ping me in this video's description. I'm gonna come back and reply you regarding the support here. So let's get started and see how to build this solution for this particular lab session. Hey, hi. In this video, I will show you how to build an API to generate a video with using AI technology. So here, I'm going to use AWS services like Lambda and then Amazon Bedrock, where we're going to use the Luma Ray foundation model, which generates the AI. With using these two services, I'm going to construct an API so that you can use that API and generate a video like any other services. So here I'm going to show you from scratch to end, like, how to write the code that would interact with the Amazon Bedrock foundation model. So, and then, how to write a code that can talk to the Amazon Bedrock. And eventually this Lambda URL will be acting as an API. And if you try to invoke that API, you're going to generate a video, and video is basically text to video kind of AI. So here, how did I construct this particular API that it becomes usable at enterprise level or at any learning or anywhere you can use this API in your application. So let's get started and see how we can construct this lab session in this video, and then we're gonna see the demo of when I invoke this API, it returns me an URL, and that URL lets me to download a video which is generated by AI. So this is my AWS account, and we are currently in Amazon Bedrock service. So if you go to the main search bar and type for Amazon Bedrock, so you're gonna get this link. When you click on this link, it will take you to this service page that is Amazon Bedrock, and then click on a discover catalog. So within this catalog, we're gonna search the Luma AI. So underneath the Luma AI, so there is a foundation model called Ray, which actually provides capabilities like image to video, text to video, right, and video generation. So here we are experimenting text to video via API. So in the sense, how do I build an API with using AWS services that can talk to this Amazon Bedrock foundation model and create a video based on an API invoke. So that is what I'm showing here. The prerequisite here is make sure that you have access to this particular foundation model from the Amazon Bedrock. So I have requested the access and they have granted me so that I can use this foundation model via model ID. Now I will go to the another service which I showed in the beginning. So that is AWS Lambda. So we have created an AWS Lambda, and AWS Lambda name is basically it is the Lambda name is I have created one Lambda called create basically invoke video gen AI. So the name of my Lambda which I created is invoke video gen AI, and it has a function URL. Right. Right now I'm not using this functional URL, but I'm using the Boto 3 APIs to invoke this Lambda and then generate the output basically, which is nothing but a URL of a video, or basically a URL of a video which is generated by foundation model like that. So this is the piece of code which I'm going to walk you through, and we're going to see the demo here, right? So with that said, I'm going to go back to my source code, and then we're going to see the demo. So here I have a code, source code, Anyways, I'm going to share this source code in the video's description. You can find it from there and try to use it from your side. So let's quickly see what did I do in the source code, which will generate the video based on the text, right? And this is very simple code, by the way. It uses the Boto 3 model of Python, that is Python SDK for AWS, right? And then this is where you see that we have imported that, and these are all my variables. So to invoke the Luma Ray text to video generative AI, you need an S3 bucket. So I have created an S3 bucket. This is the S3 bucket is being created. I'm going to show you that bucket as well, so that you are confident on how the solution works and how does the backend services also interact with each other in the real term, right? So that is where I'm showing you here. So if I copy paste that, basically if I try to copy that particular bucket here, so this is the S3 bucket we created and we are using in the this solution configuration. So if I open this bucket, so there are a lot of folders in there. We're going to see what are those folders, by the way. Let me jump back to the code. So that is where our variable is all about, that is bucket name. Prefix is nothing but the subfolder within the S3 bucket where the generative AI video will be stored. And then prompt is nothing but that is nothing but the text message that you want to give it to the foundation model, and based on the text message the Luma Ray AI will generate a video for you, right? And then down the line we are creating a Boto 3 clients for Bedrock runtime, and a region, in which region you are using the Bedrock runtime, right? So we are using US West 2, so that's the reason we have US West 2 region, and constructing a Bedrock runtime client, and then creating a client for S3 bucket as well. Now this is the function which will actually invoke the Luma, it's not a Llama, Luma Ray foundational models. And this is the foundational model ID, which I showed it earlier. And we are constructing the input that is needed to invoke that particular model. And that, model input structure is nothing but something like this. It has a prompt. Prompt is nothing but the message that we have constructed here. And then it has a duration that is 5 seconds. So it's going to create a 5 seconds video. Resolution of the video will be 720 pixel. For now they support two types of pixel, 540 and 520 pixels, and then the aspect ratio is 16 comma 9, right? And then the output data configure. So output data in the sense these foundation models work in conjunction with the AWS services like S3 bucket. So it generates a video, but it needs a space to store the video. That is where it will ask the S3 bucket, and the S3 bucket URI will be given here. And then we are going here into the next API. So underneath the client, that is Bedrock, we have an API called start async invoke. So when I call this function called start async invoke, which means that Amazon Bedrock foundational model has a capability that it can receive the API invoke asynchronous manner. So that's the reason it will start the asynchronous invoke. And then where we are passing the parameters like model ID, model input, and the output configuration that I showed above. Now, once that asynchronous invoke gets invoked, you're gonna get one return. The return is nothing but invocation ARN. Now you got an invocation ARN. With that invocation ARN, you need to do a further job, in the sense with using that invocation ARN, you need to keep polling the APIs of Amazon Bedrock and get the response whether that invocation has gone complete, failed, or in progress, like that. So for that, again, we are calling another function called wait for a job. So with the parameter invocation ARN, which is collected from above functions, right? And here what we are doing is, we are just polling the Amazon Bedrock API to check the status of that. So here is where you have the client Bedrock and calling a function called get asynchronous invoke, where invoke ARN is passed as a parameter, and then check the status, right? You keep doing this one by periodically with a sleep, and then you keep doing that job basically, right? Until the status goes complete, failed, or something else, this process will continue. This in the sense this function will continue to run. And then so since the generated video is stored in the S3 bucket, I need a URL so that I make this code usable, right? So I need a pre-signed URL of that particular video. So that is what it does. So it contains a bucket, key name, and the expiration is being given. So here I'm generating a pre-signed URL and passing it. That's very simple. In the sense, it is getting, it is basically returning an URL of a video. If you use that URL and browse it in the browser, any browser, that video gets generated, downloaded for you, and you can run that video, right? And that is all about. And this is basically orchestrating function, that is text to video. So it contains a prompt, bucket, and prefix. So it calls the about three functions that we just know, about two functions that we just now started. So one is invokes a Luma array function, then other one is wait for a job. Once the wait for a job is done, it gonna gets the pre-signed URL. So you can look into this code very detailed. And this is our run main function. That is basically, this is how it will we are invoking. So it calls the orchestration functions, and then the code gets generated. Okay. And I have wrapped this same function in the AWS Lambda. Now you see that how I am constructing myself so that I build an API for an application, right? So now I have the code which will run in my local laptop. Now I need to run it, I need to wrap that code into a Lambda runnable Python code. So there is nothing much change here. You're gonna keep it as simple as that, but it has the imports like Boto3, JSON, time, like that. Variables will remain same if you see here, and then everything will remain same. But here you will have, instead of this one, instead of the main function here, a run function from the local laptop, for Lambda, it's gonna slightly change. That is, you will have the handler functions. So from the handler functions, what we are doing is, we are actually receiving the prompt. Why? Because Lambda here is acting as an API. So when you call that API with a parameter, you need to read the parameter. So in the parameter, what we are passing right now, I'm passing prompt, but you can also pass the other parameters like video length, video resolutions, something like that, right? And then you are here again down the line, it invokes the Lumare functions, wait for a job, returns the basic. Again, it will do a certain invocations to return the pre-signed URL. That's it, right? It's very simple. So this code, this code I have kept where I have deployed this code in my Lambda. So this is where the code is all about. So if I enlarge this one, if I make it big one, so this is basically our source code is being kept here. All right. And now, so again, I'm not invoking this particular functions from this Lambda here by doing a test, but I do it as an application usage. How? I will invoke that Lambda from my laptop again. Like, and consider that my laptop is running a source code of your application. So I have a piece of code being written to do the same as well. So here we are again having a small piece of code called which will invoke our Lambda by using the Boto3 APIs, right? So it is very simple. So it has the Boto core config, the import, and then here is our variables, that is reason and my Lambda name. So what is that I'm doing is I'm creating a Lambda client, and from the Lambda client I'm calling a function called invoke, which will invoke the Lambda with a parameter and receives the return, right? So that is what it is doing here. It's very simple. So we constructed the client. If you see here, this is our config. So why config here? Because the processing of the Lambda is time consuming. It takes nearby 1 minute to give the output. So that's the reason we have added certain extra config which contains the connection timeout and the read timeout. And then with using that config, we are constructing the Lambda client. Here is our payload variable that is used in the Lambda client invoke function. This is the Lambda name, request response, right? And then the payload. All right. And then very simple, we are just invoking that Lambda with these set of parameters. And then from the output, we are extracting the the URL, that is the video URL. Okay. And this is the another code is, this is basically a helping code that you can use it. No worries, I'm going to share all the 4 codes in the video's description. You can try it from there. Now, as I shown in the first part of the video, that is how I'm building an API which can generate video, right, with using Amazon Bedrock. So let's try to run this particular function, that is invoke Lambda. So remember that, here I'm running the Lambda from my laptop, which is basically mimicking how you can make use of capabilities of AWS, basically Amazon Bedrock's foundation model, that is Lumare, which is a text generative AI model, right? Now I have just now invoked my Lambda. So this is running the Lambda under the hood, and it will create a video for us. And I'm going to download that video and play the video in front of you now. So since it takes nearby, more than 45 seconds or like minute, I'm gonna go on a pause and come back. So after waiting for more than 30 to 45 seconds, you see that invoke lambda code has written something. So I'm just sharing my screen entirely, and our video URL is this one, right? So when I click open this one, that is basically control and click. So it will open a URL, right? Nothing but that is a URL where you can download a video. You see that a video got downloaded, and I'm going to open that video in front of you. So what is that? This is nothing but generative AI generated video. So you see that it is a dragon that is flying over the mountain. So let me see the prompt here. So if I go back to the prompt, what did a prompt we have given? So we have given a prompt called a cinemata, basically a cinematic dragon flying over the mountain at sunset. Okay, so let's see, if the generative AI has taken care of those, keywords. So first one is cinematic dragon. So of course this is a cinematic dragon, and then here is a mountain and the sunset as well. So basically, and this is a 720 pixel clarity video, right? And it has done the job. So now this is how basically you can build an API that can talk to the Amazon Bedrock foundation model and do the job with the prompt. So here we texted and it generated the video, which is very good, basically the solution, I would say. So finally, I have shown the things need to be shown in this lab. Finally, a can't request, please do subscribe my channel. That would really encourage me a lot. With that note, thank you. Thanks a lot, and see you in the next video.